The best nutraceuticals that I've discovered is a plant chemical called quercetin. Okay. Now, before I start this video, I want to remind people I'm not a doctor, I'm not a nutritionist, I'm not a dietitian, I'm not a nurse of any kind. I don't practice any form of medicine. If you have any medical issues or any medical questions, talk to somebody that is a licensed medical practitioner, not some guy on YouTube like me. So how did I come across quercetin? Well, I've said this a lot. I've made a lot of videos about quercetin, but quercetin I came across due to lung issues that I developed, and nobody really knew why I developed these lung issues. It got to the point where my family doctor had assumed that I had pulmonary fibrosis. I looked up things that help to reverse fibrosis, and one of them is quercetin. It also helps with asthma. Later, I was diagnosed with asthma. I really discovered quercetin when I was looking up things for a friend of my karate instructor who had 2 children that have pulmonary fibrosis. And quercetin was shown to help with pulmonary fibrosis. So what are the health benefits of quercetin in relation to age-related diseases, and why am I talking about this? Okay, so a lot of people talk about resveratrol. I didn't find resveratrol to be that amazing. I took it because people said it was this great thing, yada, yada, yada. But I'll tell you what, taking quercetin really did help a lot with a lot of my issues. I look much more youthful now. I have much more endurance. And a lot of the lung issues I had are not really there anymore. So, let's talk about this. Polyphenols are the known group of phytochemicals that essentially consist of phenolitic rings, blah, blah, blah. Okay, so, quercetin, the Latin term for the flavonoid, quercetin, means oak forest. This belongs to the class of flavanol, and is not synthesized in the human body. Quercetin is known to use in the treatment of cancer, allergic reactions, inflammation, arthritis, and cardiovascular disorders. The flavonoid also plays an important role in platelet aggregation and the peroxidation of lipids, and enhances the biogenesis of mitochondria. Quercetin is a potent molecule that can be used to cure various health-related issues. Quercetin manifests antioxidant properties, both in vivo and in vitro. Free radical scavenging activity of quercetin protects from various age-related disorders. A diet rich in quercetin has various health-promoting benefits. It acts as an agent to lower coagulation, hyperglycemia, inflammation, and hypertension. Various clinical studies show that supplementation of quercetin is used to prevent and treat various chronic diseases such as cardiovascular disorders. Polyphenols and oxidative stress. Polyphenols are compounds that have antioxidant properties and are known to protect cells against oxidative stress, and hence lowering the chance of occurrence of diseases associated with the disparity in production of reactive oxygen species and antioxidant mechanisms. This imbalance, so essentially antioxidant mechanisms neutralize them. It's referred to as oxidative stress. This imbalance leads to the damage of molecular components such as nucleic acids, such as RNA and DNA, lipids, and proteins. Polyphenols are known to interact with the reactive nitrogen species and reactive oxygen species, can terminate the chain reaction before the viability of the cell is severely affected. Radical oxygen species includes hydroxyl radicals, hydrogen peroxide, superoxide anion, and nitric oxide. These are the free radicals that contain oxygen and are highly unstable and reactive because of the unpaired electrons. These are important for the homeostasis and maintenance of cellular functions and are produced in cells in lower concentrations for their normal functioning. Polyphenols, based on their chemical structure, can be classified as flavonoids or non-flavonoids. Flavonoids include flavones, isoflavones, flavonols, chalcones, anthocyanins, and non-flavonoids including phenolic acids, phenolic amides, and stilbenoids. These are composed of several aromatic rings with hydroxyl blah blah. Polyphenols have a role in the prevention of neurodegenerative diseases, cardiovascular diseases, cancer, and type 2 diabetes. Polyphenols are produced as a defensive mechanism as a consequence of UV rays and as protection against certain pathogens and predators. Polyphenols are known to possess antioxidant, anti-inflammatory, and antimicrobial properties. These properties are further known to reduce the risk of certain diseases such as cancer, neurodegenerative disorders, obesity, and cardiovascular diseases, which are known to be related with age. Studies have correlated the activities of various edible polyphenols in the diet with the process of aging. The exact anti-aging mechanisms of polyphenols, however, remains unexplained. The effects of aging can be observed at cellular tissue and organ level. At the level of cells, the polyphenols reverse the effect of aging by reducing the damage on the proteins and DNA, and also inhibit the senescence of cells to produce senescence-associated secretory phenotype. So what this does is it helps reduce senescence, it helps to inhibit senescence, and it helps to stop the senescent cells that would in turn signal other cells to become senescent. Dietary flavonoids or become inflamed, cause inflammation. So quercetin helps stop the inflammatory process and the senescence process. Dietary flavonoids such as quercetin and myricetin have a preventative function against oxidative stress and aging. Keep that in mind. They have a preventative function against both oxidative stress and aging. Okay. While increasing, so they decrease the level of malondialdehyde and increase glutathione and membrane sulfur. These are antioxidants. Polyphenols are known to these are what are called endogenous antioxidants. The glutathione and the sulfuridyl. Polyphenols are known to exhibit antioxidant. So an endogenous antioxidant is one that your body makes. An exogenous antioxidant is one that you take in through food or what have you. These are known to act against inflammation by mainly inhibiting the activity. Polyphenols are the scavenger for reactive oxygen species and also activates the activity of NRF2, which further activates several other enzymes which acts as an antioxidant. Polyphenols act as potent antioxidant molecules and prevents heart disorders. It lowers the damage in the cardiac tissue which occur as a result of reactive oxygen and nitrogen species. Excessive production of reactive oxygen and nitrogen species causes damage to the macromolecules, nucleic acids, lipids, and proteins, and leads to the death of neuronal cells. Higher production of reactive nitrogen species ultimately leads to the occurrence of neurodegenerative disorders. Quercetin availability, physical and chemical properties. Quercetin is one of the widely occurring secondary metabolites in the plant kingdom. This forms a common ingredient of the daily human diet. Quercetin belongs to a member of the flavonol group and is considered as polyphenol to occur in abundance in nature. Quercetin is commonly present in glycosides. It is found conjugated with residues of sugar. The structure and major classes of quercetin have been depicted in Figure 1. The word quercetin is a Latin term for quercetin. The word quercetum is a Latin term for quercetin, which means a compound that is yellow in color. This compound is easy to dissolve in lipids and alcohol, is insoluble in cold water, and has poor solubility in hot water. Quercetin is most commonly found in large quantities in different fruits and vegetables, which include apple, berries, cherries, red leaf lettuce, onions, asparagus, and in small quantities in pepper, broccoli, peas, and tomatoes. It is also known to be present in citrus fruits, seeds, and nuts, and red grapes. Onion is known to possess the highest quantity of quercetin. Quercetin is also known to be present in herbs such as dill, certain varieties of tea, and wine. Quercetin is known to be found in various medicinal plants such as ginkgo, American elderberry, and Hypericum species. Various sources of quercetin have been depicted. Common sources of quercetin have been depicted in Table 1. So this is Table 1. So you have onion, capers, green tea, apples, broccoli, red leaf lettuce. Polyphenol quercetin was first isolated and recognized by Georgi in the year 1936. The chemical formula for quercetin is C15H10O7. The structure shares a common flavonucleus made up of two benzene rings and is connected by a heterocyclic pyrrone ring. This flavonoid is known to possess antioxidant properties. This is also known to have a protective function against aging. The dietary flavonoid quercetin is made up of 3 benzene rings and 5 hydroxyl groups. This is commonly found in different vegetable stems, flowers, tea, wine, roots, and bark. It is a crystalline bitter compound. It is responsible for giving colors to various flowers. It is an aglycan and does not include any carbohydrate moieties. The different sources of quercetin from various fruits and vegetables have been shown in Figure 2. Okay, so these are different sources of quercetin here. These are little pictures of them. Quercetin is considered to be one of the most studied flavonoids. The flavonoid quercetin is derived from the amino acid phenylalanine. Quercetin is mainly produced via phenylpropanoid pathway. The initial steps involve the synthesis of cinnamic acid via phenylalanine, ammonia, blah, blah. Okay, various in vivo studies suggest that quercetin has the ability to inhibit xanthine oxidase as it decreases the formation of free radicals and is hence considered a potential antioxidant. The oral bioavailability of quercetin is very poor, and this depends on its sugar moieties. Quercetin present in plants is mostly in the form of hydrophilic glycosides, which inhibit its direct absorption. The absorption of quercetin becomes as high as 65 to 81% after glycoside hydrolysis to its aglycone form. Quercetin is used as a dietary supplement. The safe dosage for quercetin is 1 gram per day, and the absorption is up to 60%. It is available in both free and conjugated states. The conjugated form of quercetin includes quercetin glycoside, quercetin sulfate, quercetin ethers, it should say esters, I believe, and prenulated quercetin. Flavonoid quercetin has antioxidant, anti-inflammatory, and anti-proliferative properties. It is also known to have anti-diabetic, anti-carcinogenic, and antimicrobial properties. Quercetin is a scavenger for free radicals and therefore is considered a potent antioxidant. Quercetin is lipophilic and hence passes through the plasma membrane easily. Quercetin has very low solubility in aqueous medium, and its metabolite and chemical stability is also very poor and restricts its permeability to the membrane. Hence, it has a very poor oral bioavailability. Recent study shows that quercetin has the capability to trigger and modulate chromatin modifiers, which include histone acetyltransferases, HMTs. That quercetin reduces the activity of chromatin modifiers in dose-dependent matter. It also decreases the total methylation of DNA as well. Studies on a filamentous ascomid fungus, blah, blah, showed the function of Okay, when treated with compound, quercetin induced longer lifespan. So quercetin does induce longer lifespan. In that fungus, at least, quercetin treatment increases the lifespan of wild type. Quercetin administered also increases the respiration in mitochondria, meaning it helps to correct mitochondrial dysfunction, and mitochondrial dysfunction happens with age, of course. Quercetin has antihypertensive and vasodilation effects that dilate arteries, which indicates ameliorated circulation. Treatment with quercetin regulates blood glucose and lipid levels during fasting, decreases the amount of fat deposition in the liver, reduces the severity of renal fibrosis, and plays an important role in the AMPK-dependent autophagy process. Obese mice, when fed with quercetin, resulted in weight loss and lowered level of triglycerides and level of cholesterol in the plasma, and hence improved the metabolic conditions. A report suggests reassembling of white adipocytes to brown-like adipocytes. Quercetin, due to its antiviral properties, is known to inhibit polymerase, reverse transcriptase protease DNA, so it basically deactivates various viruses. After ingestion, the glycoside becomes hydrolyzed and releases a glycone, which is absorbed and metabolized and gives rise to other glucocorrodidated sulfate and methylated forms. The glycosidic form of quercetin includes hyperside, rutin, and isoquercetin plant families such as Solanae. Okay, these are the different passion flower, nightshade, I don't know all these, but by the top of my head. Glycosides are responsible for the cleavage of glycosidic bonds after oral intake. This has a protective mechanism against osteoporosis, pulmonary disorders, and venous illness as well. Quercetin accounts for about 75% of the total flavonoid in the dietary intake. Rutinose is a sugar conjugated from quercetin. Among all the flavonoids, glycosides of quercetin are known to have better absorption in the case of humans. It has a rapid metabolism and is excreted without accumulation in the body. Quercetin is mostly absorbed in the small intestine. Okay. It is mostly absorbed in the small intestine. The absorption of only about 5 to 10% of the compound is in the small intestine, whereas 90 to 95% is absorbed in the colon region. The quercetin that has been ingested from quercetin is an antioxidant. Okay, quercetin is a potent scavenger of free radicals. Okay, we already kind of went over this. Owing to its chemical structure, quercetin has the ability to scavenge free radicals, which include hydrogen peroxide, superoxide, and hydroxyl radicals. Okay, the catechol group present in the B ring, blah, blah, blah. Okay, so let's see here. Quercetin is known to have high solubility and bioavailability, and hence exhibits antioxidant properties after it forms a complex or combines forming novel preparations for usage by humans. Quercetin maintains the oxidative balance and hence is a strong antioxidant. It regulates glutathione levels in the body. Studies on animals and cells show that the synthesis of glutathione is induced by quercetin. The increased expression of superoxide dismutase, I don't know what that is, and glutathione has been reported with the pretreatment of quercetin. Extensive studies show that quercetin interacts directly with DNA. Quercetin binds covalently with DNA. It is still unclear whether quercetin repairs DNA or protects it from oxidative damage. The antioxidant effect of quercetin DNA was found to be greater than that of quercetin alone. Quercetin is a known flavonoid that, when present in circulation, ameliorates vascular health, and when present in conjugated form, reduces the occurrence of cardiovascular disorders. Quercetin exhibits its antioxidant activity and can lower the severity of senescence. In case of mice, increases lifespan, as well as increases lifespan in nematode worms. Quercetin and its other derivatives prevent blood coagulation and reduce the occurrence of stroke. Quercetin is a potent scavenger of free radicals, radical oxygen species, and hence protects the body against oxidative stress. Quercetin is known to affect the stability and fluidity of the lipid bilayer layer and influences the activity of ATP-dependent protein transporter. The different properties of quercetin and its mechanism of action has been depicted in Table 2. So it's anti-inflammatory, anti-cancer, antioxidant, and anti-hypertensive, as well as anti-diabetic. Neurodegenerative disorders. Flavonoids prove to be beneficial in preventing neurodegenerative diseases and might delay the neurodegeneration process. Studies prove that neuroprotective functions of quercetin, the neuroinflammatory process is suppressed by quercetin as it downregulates pro-inflammatory cytokines, which include these cytokines here. Okay, quercetin reduces the lipid peroxidation and hence prevents the oxidative damage of neurons, neuronal cells, when treated with lower concentrations. Quercetin functions as antioxidant, and higher concentrations become toxic. Even though quercetin has low bioavailability, it can pass through the blood-brain barrier due to its lipophilic nature and functions as neuroprotective. When the mouse model was treated with quercetin via injection, 48 hours for 3 months, extracellular B amyloidosis, so it stopped beta amyloid plaques, was found to be decreased, so it decreases beta amyloid plaques. The accumulation of beta amyloid plaques in the brain is presumed to be the main reason for the development of Alzheimer's disease. It has been reported that quercetin lowers beta amyloid accumulation in the brain. Quercetin administration has been proved beneficial to improve learning and memory efficiency, and it also reduces the activity of acetylcholinesterase, so it helps to increase the amount of choline. Quercetin is known to inactivate these various signaling pathways by downregulating the proteins which induce Alzheimer's disease. The oxidative damage of an individual is compromised as aging proceeds. Increased oxidative damage is a major factor responsible for the occurrence of age-related neurodegenerative disorders. Oxidative damage, dysfunction, and mitochondrial autophagy and defective neurotransmitters are some of the important factors which are responsible for the causation of neurodegenerative disorders. Studies on quercetin possibly show that it exerts an effect on the central nervous system. Quercetin is known to exert a protective role against neurodegeneration. The compound is known to improve the activity of superoxide dismutase and catalase and thus prevent the depletion of glutathione. Diabetes. Natural substances are inexpensive and can be easily obtained and therefore can be used as an alternative to treat diabetes and other pathologies. Quercetin, due to its antioxidant and anti-inflammatory, hypoglycemic, and hypolipidemic activities, is known to be involved in the treatment of type 2 diabetes. Quercetin reduces the concentration of blood glucose levels, preserves the function of islet cells and number of beta cell numbers in model rats, so it basically prevents the pancreas from dying. With diabetes, experiments show that quercetin intake has a positive impact to prevent and treat the occurrence of diabetes, type 2 diabetes. Quercetin treatment of diabetic rats improved dyslipidemia, decreased the blood glucose level in serum, increased the level of insulin, and decreased oxidative stress. When quercetin was orally administered in rats, the sexual activity, sperm count, and motility and testicular damage induced by diabetes was reduced. When administered intravenously, quercetin lowered blood pressure in hypersensitive rats. Quercetin reduces the effect of oxidative stress and also attenuates the beta cell injury of the pancreatic cells, so it helps preserve the pancreatic cells. It has been reported that consumption of the compound reduces the injury of hepatic cells, meaning liver cells, oxidative stress attenuation, and elevates the antioxidant enzymes such as catalase and heme oxygenase. The administration of quercetin in diabetic mice for 10 days of 10 and 15 milligrams per kilogram shows a decrease in blood glucose level and triglycerides, while it increases the activity of enzymes such as hexokinase and glucokinase. Quercetin is regarded as a very important flavonoid with beneficiary metabolic functions. Studies performed showed that the oral administration of 75 milligram per kilogram of quercetin to diabetic rats reduced the number of placental glycogen cells as compared to the control group. The plant compound acts as an oxygen scavenger, as has been covered ad nauseum now. The antioxidant properties of quercetin prevents the in vivo and in vitro oxidation of biomolecules. Cancer. Quercetin is a potent flavonoid known for its chemoprotective activities in various in vivo and in vitro models. The various anti-cancerous properties, such as reduced proliferation and the ability for induction of apoptosis, meaning programmed cell death in cancer cells, inhibition of metabolic events causing cell cycle arrest, makes it a reliable molecule in the therapy for cancer. Quercetin can be used as a potent therapeutic, but it has poor solubility, poor permeability, and low bioavailability. One major drawback of quercetin is its instability, which limits its usage as a therapy for cancer. The molecule is insoluble in water and very less soluble in alcohol. Studies on quercetin were performed by dissolving it into an organic solvent to increase the clinical dosage of quercetin. In cancer treatment, the molecule was used in higher concentrations and was frequently administered. Therefore, other alternatives were developed to use quercetin clinically, and hence nanoparticle formulations were made to overcome the above-mentioned drawbacks. The nanoparticle formulations of quercetin were more effectively used in biological systems in the treatment of cancer. Quercetin, when encapsulated in a nanoparticle system, improved it as an overall anti-cancer agent. Treatment with appropriate dose makes quercetin non-toxic and shows inhibitory effects on the formation of tumors. Various in vivo and in vitro studies show that quercetin promotes apoptosis, inhibits metastases, and regulates cell cycle. In colorectal cancer, quercetin arrests the cell cycle, modulates receptors of estrogen, regulates signaling pathways, and hence exhibits its chemoprotective functions. It has been studied that in leukemia, in the case of human quercetin, arrests the cell cycle at G2. Quercetin is also known to regulate p53-related pathways in cancerous cells. It regulates the release of p53 and hence inhibits the activities of cyclin A, cyclin B, CDK2, and therefore stagnates the MCF-7 cells of breast cancer. Quercetin affects the apoptic pathways of the cancerous cells and therefore induces the death of cancer cells. Treatment with appropriate dose of quercetin increases the pro-apoptic protein expression, meaning it helps encourage programmed cell death in the cancer cells. Okay, so let's move on here. Anti-inflammation. Various studies in cells, human and animal models, suggest that quercetin exhibits anti-inflammatory actions. Okay, so conclusion: phytochemicals are the plant product which are present in different fruits and vegetables. The phytochemicals, blah blah blah. Quercetin is a plant secondary metabolite which occurs widely in different parts of the plant. It forms a basic constituent in the human diet. Quercetin is known to possess antioxidant properties and has a protective function against aging. So it does have a protective function against aging. The flavonoid is comprised of 3 benzene rings and 5 hydroxyl groups. It is a flavonoid that lacks sugar moieties in its structure. Quercetin is often used in the human diet. Quercetin is known to have antioxidant, anti-inflammatory, and anti-proliferative properties. It also possesses anti-diabetic, anti-carcinogenic, and antimicrobial properties. Quercetin has a rapid metabolism and is excreted without accumulation in the body. It has an extremely short half-life in the blood, owing to the presence of phenolic group and a double bond. Quercetin shows potential antioxidant activities. The molecule is known to be a potent scavenger of free radicals in the flavonoid group. Quercetin possesses both antioxidant and pro-oxidant properties. It maintains the redox balance of the body and shows increased expression of superoxide dismutase, CAT, and glutathione. Quercetin has a role in age-associated diseases. Being lipophilic in nature, quercetin easily crosses the blood-brain barrier and exhibits neuroprotective activity. It exerts a protective role against neurodegeneration. The molecule is known to lower blood glucose levels and preserves the function of the beta cells in diabetic rats and mice. It shows a positive impact to treat and prevent diabetes. Various in vitro and in vivo studies have shown that quercetin has anti-cancerous activities and can be used as a reliable drug in cancer therapy. Quercetin has a crucial role to play as an anti-inflammatory molecule. To conclude, quercetin is a potent molecule and can be used as a tool to cure various age-associated disorders. So what are some of the restorative effects of quercetin? Okay, so the antioxidant flavonoid quercetin is a plant polyphenol that may be beneficial for retarding the aging process. Okay, examine the restoring properties of quercetin on human dermal fibroblasts. Quercetin directly reduced either intracellular or extracellular radical oxygen species level in aged. Okay, so to find the aging-related target genes by quercetin, microarray analysis was performed, blah, blah, blah. Okay. So essentially, taken together, these results suggest that quercetin has a restoring effect on the cellular senescence by downregulation of senescence activities and upregulation of the gene expressions of antioxidant enzymes. What are some of the anti-aging and rejuvenating effects of quercetin? Homeostasis is a key of the cellular lifespan. Its maintenance influences the rate of aging, and it is determined by several factors, including efficient proteolysis, okay, the proteasome, okay, lifespan, okay. Moreover, okay, so activities and function are decreased upon replicative senescence, whereas proteasome activation confers enhanced survival against oxidative stress, lifespan extension, and maintenance of the young morphology longer in human primary fibroblasts. Several natural compounds possess anti-aging antioxidant properties. In this study, they have identified quercetin and its derivative, namely quercetin caprylate, as a proteasome activator and with antioxidant properties that consequently influence cellular lifespan, survival, and viability, primarily in human fibroblasts. Moreover, when these compounds are supplemented to already senescent fibroblasts, a rejuvenating effect is observed. Finally, they show that these compounds promote physiological alterations when applied to cells. In summary, these data demonstrate the existence of a naturally occurring anti-aging products that can be effectively used through topical application. So what about quercetin and its anti-aging and anti-cancer properties? The flavonoid compound quercetin offers unique anti-aging properties that can help to prevent healthy cells from aging while promoting senescence in harmful cancer cells. Quercetin comes from a group of phytonutrients that give fruits and vegetables those vibrant colors and are known for being potent anti-inflammatory and antioxidants. They exert modulating effects on the immune system. It is abundant in the human diet. On average, people consume 10 to 100 milligrams of quercetin every day from food sources, which is good for health. The antioxidant properties can help to neutralize free radicals that play roles in chronic diseases, including diabetes, vascular disease, and cancer. The flavonoid can also be sourced as a dietary supplement, which typically contain 500 to 1,000 milligrams of quercetin, but it is best to obtain it directly from food to boost intake of this beneficial compound. Some of the best food sources include black tea, blueberries, asparagus, broccoli, cherries, citrus fruits, cranberries, green peppers, green tea, raspberries, red onions, shallots, yellow peppers, white onions, red grapes, kale, red leaf lettuce, and red apples. Antioxidant and anti-inflammatory properties have helped to prevent heart disease, protect against neuronal loss, enhance cognitive functions, and benefit of biological activity, also help to delay or prevent cellular aging, and induce the death of cancer cells. It has also shown potential for reducing inflammation caused by senescent cells and preventing healthy cells from entering senescence by encouraging their normal cell behavior and slowing down cell aging processes.
It induces cell senescence in abnormal cells in cancer, as well as inhibits their proliferation. Combined with tocotrienols, they are most formidable against cancer cells. Anti-aging benefit. Tocotrienols are another form of vitamin E. Tocopherol is usually what you find in supplements. Anti-aging benefits are not limited to preventing senescence. According to a study in experimental gerontology, it can also help to rejuvenate senescent cells, meaning it makes old cells young again. Treatment with quercetin and quercetin caprylate was found to promote physiological alterations to aging cells that extended lifespan and promoted enhanced survival and viability. Okay. Low-dose quercetin positively regulates mouse lifespan or health span. Aging is a leading risk factor for many chronic diseases, accounting for almost 60% of all deaths worldwide. How to achieve healthy aging, alleviate aging-related diseases, and extend health span has become a main topic of biomedical research. Geroprotective compounds such as metformin and rapamycin have been shown to improve both health span and lifespan, whereas nicotinamide partially improves health span in mice. In addition, senolytic compounds that eliminate senescent cells have been proven to improve physical function and increase lifespan, although none have proven to be clinically reliable in delaying aging or treating frailty in humans. These compounds have already provoked enthusiasm for identifying a potential elixir. Therefore, the exploration of more geroprotective compounds, especially natural active compounds, holds great potential for the development of geriatric medicines. Quercetin is a natural bioflavonoid found in fruits and vegetables such as apples and onions, in combination with danestib, which is a chemotherapy drug, has been shown to effectively eliminate senescent cells via induction of apoptosis, thus alleviating senescence-related phenotypes and improving physical function and lifespan in mice. In addition, quercetin 10 milligram per kilogram in combination with danestib has been reported to reduce hepatic steatosis in each of these in vivo studies. However, quercetin was used at high doses ranging from 10 to 50 milligrams per kilogram of body weight, which raises concerns about dose-dependent side effects such as headaches and limb tingling. As a selective tyrosine kinase receptor inhibitor, danestib is associated with warnings. Okay, blah, blah, blah. Quercetin as a geroprotective agent that counteracts accelerated and natural aging. 100 times lower than the concentration of quercetin previously used in combination with danestib. To explore the geroprotective effect of low-dose quercetin monotherapy in rodents, they evaluated blah, blah, in vivo. Okay. Low-dose quercetin alone improved the health span of physiologically aging mice. Experimental design for drug administration, hair loss evaluation, hanging endurance, blah, blah, blah. Okay. Data shown as mean. Okay. To investigate how quercetin improved health span in mice, they collected 11 different kinds of data. Further explore. Okay, further explore molecular mechanisms of beneficial effects of quercetin. They performed a whole transcriptome RNA. Okay, so activation of retrotransposable elements was repressed in quercetin-treated mice and certain mouse tissues. Okay. In senescent cells, activation of okay. Chemical screen identifies a geroprotective role for quercetin in premature aging diseases. Okay, so aging increases the risk of various diseases. The main goal of aging research is to find therapies that attenuate aging and alleviate aging-related diseases. In this study, they screened a natural product library for geroprotective compounds using Werner syndrome. Werner syndrome is a disease that causes premature aging. 10 candidate compounds were identified, blah, blah, blah. Okay. Hutchinson's, okay. Taken together, our study identifies quercetin as a geroprotective agent against accelerated and natural aging. So it protects against accelerated aging from things like Werner syndrome and also natural aging. Long-term quercetary dietary enrichment partially protected against dystrophic skeletal muscle, meaning muscular dystrophy. So that's very interesting. Oral quercetin administration protects respiratory function in mice with muscular dystrophy. That's okay, so Duchenne muscular dystrophy impacts 3,500 boys and leads to muscular dysfunction culminating in death due to respiratory or cardiac failure. There is an urgent need for effective therapies with the potential for immediate application for this patient population. Quercetin, a flavonoid with an outstanding safety profile, may provide therapeutic relief. Patients, as the wait for additional therapies continues, this study evaluated the capacity of orally administered quercetin in 2-month-old mice to improve respiratory function and endpoint functional and histological outcomes. So with this, quercetin is a naturally occurring flavonoid. It protects against spinal muscular atrophy. So it protects against spinal muscular atrophy in mice with muscular dystrophy. Quercetin may protect